In this lesson, we're going to define matter and also learn how to classify pure substances as either elements or compounds. Matter is anything that has mass and occupies space. So essentially, everything around us, even the smallest atom, is considered matter because it does have mass, even though it's a very small mass, but it has mass and it occupies some space. So matter can be seen all around us. They can be in the solid, liquid, or gas phase, but everything in our world is considered matter. So we can subdivide matter down into different types. So we're going to first look at the division between pure substances and mixtures. In this lesson, we're going to focus on the left side, which are pure substances. Let's look at a statement. Elements and compounds can exist as molecules. So look at the diagram to see if you think this is true or false. From our diagram, we see that both under elements and compounds, we see an option for molecular, which tells us that they can exist as molecules. Let's look in more detail at the pure substances section of this diagram. We're going to look at elements and compounds, and then we're going to further break that down into atomic and molecular elements, as well as molecular and ionic compounds. Let's first look at elements. Elements contain only one type of atom. Note that we use the colors to represent that spheres of the same color all represent the same type of atom. So on the left, where we have the gray spheres, those are representing a single element. On the right, we see that we have spheres that are connected to each other, but they're all the same color, and so all of those spheres also represent the same type of element. On the left, these are known as atomic elements because they exist as individual atoms in nature. On the right, these are known as molecular elements because in nature they are connected to other atoms. For example, nitrogen, which makes up a large portion of the air around us, exists in nature with two nitrogen atoms bonded to each other. We don't find individual nitrogen atoms around us in nature. So some elements exist as molecular elements and other elements exist as atomic elements. Let's look at an example of fluorine. So is F2 an atomic or molecular element? In this case, we have two atoms of the same type, so two fluorine atoms. Therefore, this represents a molecular element because they are connected to one another. There are some species that exist in nature as diatomic elements. Remember, di means two, so these elements exist with two atoms connected together. It's useful to be familiar with these as we look later in the class at balancing equations to recognize how these elements exist. There are 7 of them. Notice on the diagram on the right that forms a 7 from nitrogen down to iodine. So we have 7 elements that exist as a diatomic, and 6 of those 7 form the shape of a 7. Hydrogen is also one, but it's on the opposite side of the periodic table. Compounds differ from elements because they contain 2 or more types of atoms. Notice in our drawings here that when we look at a particular molecule or compound, we see that we have different color spheres which represent different types of atoms in that compound. When we look at compounds, we see that we have molecular compounds, and these exist as discrete molecules. So for example, I have a CH4 up here at the top, so I have 1 carbon and 4 hydrogens. If I were to look at a larger sample of CH4, which is also known as methane, I would see individual molecules of methane. So I'd see a CH4, and another CH4, and so on. So they're separated from one another. If I look at an ionic compound, what I'm going to see is an array. So for example, the green and purple drawing represents sodium chloride, also known as table salt or NaCl, and I see an array of Na and Cl ions. This array can be any number of those atoms or those ions, but we're going to see we have an evenly paired number, so there's one sodium for every one chlorine. So we have our continuous network of atoms. So let's look at an example to determine which substance is a molecule but not a compound. To answer this question, let's go through and classify each of these. So A is a molecule, and it is also a compound because it has two different types of atoms in its structure. B is also a molecule because we have two atoms, but it is an element because both of those atoms are exactly the same. C is an atom, and it's also an element because we only have a single atom, so we have a single type, so it's going to be an atomic element and not a molecular element. D is a molecule, and it is also a compound because we have at least two different types of elements in that species. Therefore, B is our correct answer. It is a molecule, but it is not a compound. So molecules can be either a compound or an element. Which substance is an element but not a molecule? Let's classify each of these to determine our answer. Helium is an element. Nitrogen is an element because we only have one type of atom on both of those. C2H6 is a compound, as is NaCl, because they have different types of elements making up that species. So now we know which two are elements, we need to figure out which one is not a molecule. When we look at helium, we see that it is a single atom. There's no subscripts. It's just a single helium atom. And nitrogen is a molecule because we have two nitrogens attached together, creating that molecule. Therefore, A is our correct answer. One thing we need to be careful to distinguish is the difference between atoms and molecules. These terms cannot be used interchangeably. Atoms are single atoms of an element. Molecules are made up of atoms. Sometimes the atoms are the same as one another, as in molecular elements, and sometimes those atoms are different as they are in compounds.